So what I'm going to do in this session is I'm going to reinforce with a lot of learnings. Very practical. I'll show you a bunch of demos. What we should look at is this. Overview of Google Cloud, offerings in ML, use cases of ML, and lots of demos, and questions if we have time, based on how much time we are left with. So let me ask you a basic question. I want this to be more interactive. It's not like one way speaking and you just listening like nothing is happening here. How many stay in a rented house, and how many give house for rent? Raise your hands, both. Okay, perfect. So everyone knows about what is renting a house and staying in a house, right? So do your owner stays in your house if you rent it? Will he come inside? Yes or no? Second, would you open the door and sleep and say, hey, owner, take care of my house? Would you do that? Yes or no? Come on. Same as cloud. Cloud are a bunch of services which we built for our own necessities when Google started. We opened up those services for your usage, which is essentially you're leasing it for a period of time whenever you're going to use it. So it's a shared responsibility. You are going to use it, same time managing it, based on the access we give you. Simple? Yes or no? So think of this way. Anytime someone talks about cloud, always thinks of this analogy that you are renting someone's hardware, software, and whatever the services we provide. They're pretty much the standard services we give you. The way you have to use is according to your necessity. We will give you a bunch of documentation which will help you to learn what exactly is the service all about. So we have a bunch of services under cloud.google.com/products. So these services range from a virtual machine to a machine learning API. So these are like Lego pieces. You know, everyone knows about Lego piece, right? You take a bunch of Lego pieces, you build a Superman or a Batman according to your assumptions. And Lego pieces come with a standard definition, standard size, standard way of looking at it. You pick and choose only the pieces which can make a Batman or a Superman, right? Same goes with cloud also. You pick and choose based on your architecture. If you really wanted to build a website which scales exponentially, you pick and choose those services which can help you to do that. So nothing fancy, nothing groundbreaking, all about these services which are given to you so that you can plug and play and use. How it is given to you? We have a portal. I'll show the portal in a while, where how you can go ahead and create a service and start working on it is defined in a special way. So before going into what these services are, I'll just quickly talk about why we created all these products. How many of you use google.com for search? Right? Everyone uses it. Good. So if you ask me, or sorry, ask Google, coffee shops near me, what is your intention? What is your intention? But how an algorithm knows are you asking for coffee shops in the listing or searching for coffee shops near me keywords in the entire internet? Have you ever thought that way? That how an algorithm decides which results it has to show? So in a nutshell, Google actually takes an entire snapshot of the internet data, put it on our data centers. And have you ever thought, what is this backend database we use to store this data? So there is an answer for all this. So we, last 15 years, started building our data centers to an extent that we can actually support 7 products: Maps, Search, Android Store, and whatnot, the advertisements. All these products runs on some infrastructure. Okay, that's a basic underlying factor. And this infrastructure is what we call it as Google data centers. And these data centers are connected. I mean, they are spread across all the regions in the world. They are connected using a FiberNet cable between continents. And quick update, Google actually owns our own network. We own the FiberNet between continents. So what it makes us is, we can transfer the data faster. We can build systems which look like one application over the data center. Most powerful, most efficient, and most scalable in nature, still can be used by you. So what we thought is, we started releasing white papers telling you, if you know Hadoop, MapReduce. MapReduce is a white paper, Google released it. Not many people might not know that there is a white paper actually, because Hadoop took it up and created MapReduce. Apache Dremel, So there are multiple open source projects. Best one is TensorFlow. TensorFlow is a open source SDK which Google released it. So what we are doing over the last 15 years is we are opening up slowly the services which we are using, maybe in an IDEA way or an SDK way. Two ways of doing it. But what we decided is, you guys don't need to read about a white paper, start building again. Why don't we, for the first time, open up our data center to you so that you can start using it? So that's exactly all the products which you will be seeing in the next coming slides are going to look like. These are the products which we opened up for you to go ahead and use and build your own ideas. By the way, Google Maps is part of Google products, which means if you wanted to identify what is the location transfer, like route between point A to point B in any place in the world, you can just do an API call, get the data out. So what we started, open up so that you will use, and you will come up with the new best quality products you can build on the table. So why do we need to do that? What is the differentiation factor? The major challenge with IT generally is traditional workloads, it just goes on. And when you actually do, so basically when you have to innovate rapidly, or how many of you know virtual machines here? Great, I don't need to re-emphasize. So virtual machine has its own inherent problems. If you are running on on-premise, doesn't matter, or putting on cloud, doesn't matter. You are taking the problems from on-premise to cloud. That's what you're doing there. So what we thought is, let's innovate on it. So we have a bunch of services like Kubernetes, App Engine, virtual machines. Recently, yesterday, I think we announced hardened, like a fully secured virtual machine, where you don't need to take care of the security. So there are a bunch of innovations we are bringing onto the table, which helps you to reduce the time to innovate so that you will either succeed quickly or fail quickly. That's the whole point of all these services. And we are in the third wave. So why I didn't touch base on the first wave and second wave is we are way past the virtualization. So virtualization is all about, again, Hyper-V, running the stack, making sure that they run properly. That's almost done. Where we are in a fully managed serverless DevOps story where your job is to hook it up and use it. Just to give you a high-level blueprint of how powerful these systems are, take an example of BigQuery, which is a data warehousing solution, which can do a full table scan on 7.5 petabyte data in almost 120 seconds. It's a worldwide application. I mean, it's geo-distributed. So, and for this BigQuery, you don't need to provision any virtual machine. Zero virtual machines. All you just need to is dump the data, use the data. That's it. Now, that is where we want you to end up, not necessarily starting everything from scratch. So 3 important parallels we wanted to build, or we built our platform, is security, networking, infrastructure. I already talked about it. By the way, Google builds purpose-built servers end-to-end for our data centers, which means these are specially designed hardware for the specially designed workloads. So we know where to optimize the hardware, at the same time how to secure it. So go ahead and read about a security chip called Titan, which helps to identify if there is a tampering happening on the hardware. And that is part of Google Cloud data centers. So much innovation went in security, networking. Maybe I'll talk a quick bite about networking. At normal internet backbone speed, how much do you think? What is the normal internet backbone speed? 100 terabytes per second, maybe 200 terabytes per second, kind of. Now, Google's is 1300 terabytes per second, which means if you want to do a DDoS attack, it's more costly for you than anything happening to us. The way we can actually, it's a capacity within a data center, the speed which we can operate on, and the speed is translated to you. A virtual machine in Google Cloud hardly takes 20 seconds to create, not more than that. So let's build a small blog, a website, and see how easy it is to. For example, let's start with building a WordPress application. So what I generally do is, if I wanted to do a WordPress application, all I just go is, this is the console. I have a pre-packed solution. WordPress, I'll create a multi-solution. Launch it, and go ahead and create. So this is provided by our partner, and deploy. What we did, we took a pre-packed solution by our partner, deployed in our data center. That's it. All the parameters, we took it by default, just for your convenience. So what it is happening, just go through. What it is backend doing is, it is taking the JNGA file, essentially running a predefined configuration scripts, creating a virtual machine with WordPress loaded into it. One click, that's it. You didn't do pretty much anything. No configurations, all set in. Now how you have to do, how it will translate is this way. So these are the services available. This is like a shopping cart for services. Compute engine, this is where you end up seeing that virtual machine getting created. And that's how it is. It's already created. How much time it took? 20 seconds, not more than that. As I said, it's fully ready, a virtual machine. So let's see already a virtual machine which I created. And this is the IP. Your blog is ready. So it doesn't take much time to build your own blog. For example, if you wanted to start your own blog for some reason where you have to have control, define WordPress plugins, and do whatever the stuff you wanted to do, that's it. Go, cart, shop, then buy, start building. Everything is predefined. So there is a complexity you can add on. For example, you wanted to put this virtual machine in a predefined network which is safeguarded. We call it as DMZs, demilitarized zones. How do you do it? Create a virtual network, put it here. So it can get complexity. You can increase the complexity to an extent that you can build entire, for example, take your college websites. You can build college websites simply like this. Because all the college websites are mostly CMS solutions. CMS solutions end up becoming a virtual machine. Load balance it, scale it, you're done. So very simple, easy to use, easy to operate, just one click. Mostly when you're doing some basic stuff. And you can make it more complex and complex as you go. So let me show you what are the bunch of services we have in our platform. Cloud. As I said, what is the website I said? cloud.google.com/. Excellent. Products. Now let's go to the products and see how many are there. We have products ranging from storage, compute, migration, Kubernetes, Spanner. I mean, I can talk a day long about Spanner, management, and developer tools. Why developer tools is important? You all need to write code. And you write code on either Visual Studio, Eclipse, Jenkins, whatever the language you want, choose whatever the way you wanted to, but still have to deploy the services on Google Cloud. So these plugins are essential and integration factors with your developer tool environments to Google Cloud so that you don't need to learn anything from scratch again. Very important, Google supports a lot of open source technologies, so don't worry about getting a vendor lock-in. So you can go play and come back and deploy. Kubernetes is the best example I can say. It can run on your laptop, it still can run on your Google Cloud. TensorFlow is best example. Deploy on your laptop, put it on Google Cloud. The only difference we are trying to make here is, if you run a basic model of understanding a handwriting recognition on your laptop, it takes a year. Whereas in Google Cloud, it takes days or hours in a best way. So the way we wanted to give you is all these solutions will help to amplify you the way you wanted to work, rather than doing everything from scratch from your own stuff. But that doesn't stop you from trying them on locally. Basically, the tools can help you to build something on your local machines and have an equivalent version of something on the local machine. For example, if you wanted to train a machine learning model, you can still use TensorFlow on your laptop. The same model can be trained using Cloud Machine Learning Engine. So when you wanted to move to Google Cloud, you always have an option. If you don't, you have to set up everything of your own. So there are two pros and cons. It's open source. I mean, most of the services are compatible with open source technologies. There is no problem of getting logged in. So I don't want to talk about pricing in detail because that's not relevant for you, but try to understand we have some innovations on the pricing. We have a model where we use, I'll show you that. So we use machine learning to save you the cost. You see that orange bulb saves $16 a month. I created a virtual machine long ago. So a machine learning model will predict based on the usage of your virtual machine to resize it and give you a suggestion if you wanted to do it. So these kind of features are built into the platform so that you don't spend a lot of money on this, because we will help you to save your costs. And all the services are pay as you go. Now, let's talk about a specific section which is machine learning offerings. Because this is something which I've been getting a lot of requests in Casey, how Google Cloud or Google Cloud in a general can help students like you or developers like you. Enough examples, enough use cases. To start with, we have manufacturing, healthcare, predictive maintenance. How many of you here pay insurance for your bike? So you all pay insurance because you feel that one day your bike fails, right? But do you end up getting a bike failures every year? Then why are you paying? So a whole insurance business runs on that model that maybe you'll die someday, so pay now. You will not be able to see that. The way you can optimize that using machine learning is predictive maintenance. Put some sensors on the bike, ensure the data comes in, build a model which will say, hey, in the next 5 days your bike is going to get failed, raise a service support ticket directly to the end user, like the service support manager, saying your bike is going to come down. How much money you're going to save? So much. So there are enough use cases of machine learning. The only challenge is how you build it. So I can take a day long over the statistics, algorithms, but now let's focus on the basic practical stuff. Because statistics can come later, we can discuss later, but let's talk about the physical or the use cases as such. 3 different areas. You all are not wired on the same way. All the people here sitting are not meant for to do mathematics. How many of you really like mathematics? Okay, so everyone ends up here. There is a model where you all have to be researchers. So point here is, there is an option in machine learning. Okay, maybe how many don't like mathematics? Be genuine. I love these guys. I'm one of you guys. So, so machine learning can cater to 3 different people: a researcher, a data scientist, and an app developer. I belong to the middle and the last part because I can get more solutions more accurately rather than worrying about how they are pre-built. But you can be focusing on how to make an SDK ready or make it more better. Don't worry about, hey, I wanted to learn everything. You can choose and pick an area where you wanted to start with. You don't need to be a master in TensorFlow SDK to become an application developer. Got it? So that's what Google Cloud offers you. It gives you a wide array of solutions where you can start with anywhere and end up anything. This is something which I always tell people. If you, first rule of ML, don't build something if you don't have to build it. Right? See, how big I say, ML is all about experimentation. There is no stopping to it. And not everything can be a success. Be realistic. Now, if it is already built, why do you want to end up rebuilding it? So that's the reason we have Kaggle. Kaggle helps you to share information or do the hackathons or collaborate and make sure that you end up using or helping other people to work with your solutions. So we cover you there. Don't worry about it. Now let's talk about a bit level later, where how many of you want to use APIs built by Google for Vision? So there is an image search API, right? You do image search in your Google, right? If that is given to you, the data is given to you, how many would want to use that? Okay, so they know the value of it. Rest of them understand the value. Simple. I'll give you a solution. You have a website. You built in the next generation Facebook, and you wanted to make people to upload photos. As soon as people uploaded photos, the first thing you saw is they uploaded racy images or adult images. What would you do? What would you do? Sorry? So you have to hire a person, only his job is to see the photos. Right? Is it practical? And that's what API comes in handy. Pass it on, it will tell you. Let's see how API can be useful for you guys. What is this picture? Come on, what is that picture? It's your own picture, guys. This guy is sitting here only. You should say, that's mine. Come on. Right? Right? So what I did is, when people are actually discussing, talking, I uploaded this picture to an API and see what's happening. So what I did understand is, What I did understand from this picture is, let's do it and see what I actually saw. MDF Hyderabad, uploaded it. Wait for it. So what we are doing, taking the picture, uploading it to a Vision API, which Google has. Just give it 2 minutes, 2 seconds. What it did? It did sentiment analysis over the faces. I can tell you whether you are feeling bad for being here or happy for being here. I don't need to ask you anymore. Right? Look at the way it went to. So it did identify the faces. Unfortunately, I think he's pretty much tensed. He's not happy. But you should smile sometimes, OK? So all the information is pretty much available. And what is this picture? What do you see? What do you infer from this picture first? Excellent. Excellent. Not just you. Even an ML can tell this now. That's an audience, convention, crowd, auditorium. And the best part comes later is how many times the same image is copied in World Wide Internet. Copied, transformed, changed, whatever they wanted. Morph your image, put it across, it will identify it. Very important, copyright infringement. And this I love most. That guy has a shirt with mobile developer written on it. It does OCR. It can identify every character recognizable on the text, on the image. One click, you're done with the images. Yeah, let's go ahead. Dominant color. It just gives you black, orange, whatever the dominant color. Very important in e-commerce applications, where we end up actually cataloging or giving you a preference. Safe search. It's not an adult image, it's not spoof, it's not medical, it's not racy. For developers, you here, basically I'm an architect before I joined this role, I'm a developer. That's a JSON file. Serialize, deserialize, put it in your code, use the data. That's it. Very simple. Very simple, very powerful, one click, get it. Now let's take it to the extreme. Let's move it to the next level. What is this trailer? What is this? OK, I don't want to show you the entire trailer, but what's this? What's the trailer? Excellent. Now let's see what machine learning can identify from this trailer. OK? Let's hit up video intelligence. Come on. Look at the shots. I'll give some time. Look at the shots. Shot changes. Look at the shot labels. It exactly represents what's happening. So there are 81 shots in this trailer, out of which every shot comes with some metadata. You can all build the next generation Hotstar or YouTube. No one is going to stop you. Get this data, put it in your database, build a search engine, recommendation engine, done. Nice? Now, there's more, there's more. It also identifies what exactly is this. It identifies if there is an explicit content in any shot. Very important. API, it gives you offset data, start working on it. Very powerful, ready to use, and I love this, is if you closely observe the shots, visual effects and special effects are also taken. You will identify them also. So that's the beauty of having a Vision API, Video Intelligence API. So we have seen two APIs, which is Vision, Video Intelligence, and we also seen what are these used for. Let's talk about what is the next unstructured data you see in most markets. Text. People keep on writing reviews, and you don't know how much. You released a product, or you released a movie, and you don't know whether the movie is a hit or flop. Everyone writes their own story, and you wanted to do a sentiment analysis or the text. How would you do it? I have an answer for that. So what I did is, I took the API, the NLP API we call it as, embedded into an application, and let's see how the application look like. So this is a natural language demo portal we built, and what I did is, I submitted Kushi 2011 title. And let's see what it actually gives me back. So what I'm doing, I submitted a Wikipedia article of Kushi movie into this, and you know what it is? It does the sentiment analysis of the entire script. I mean, basically the Wikipedia article. It's positive. The best part is, this guy is a big Madhu fan. How many identify Madhu? Come on. I mean, you're born that time, right? Exactly. So this guy actually identified Madhu multiple times, remakes, film, score, I mean, based on how many important entities come in, with a proper indentation of what exactly is happening. So let's take the same example, represent it in a different way, where some basic level. Go to the NLP. What is this? Google headquartered in Mountain View. What is Google? What is Google? Come out of this wow factor, come on. What is Google? Company. Sundar Pichai? He's a person, man, come on. He's a human. So let's see what Google, ML identifies. So that's what it identifies. It tells Google is an organization, Sundar is a person, and also gives you Wikipedia articles of each and every segment. Why it is important? A lot of unstructured data, which is text, now converted to more relevant structured data you can act upon. And the best importance is it gives you sentiment analysis of line by line on the entire document. It also gives you syntax. You can build a chatbot out of it. So Dialogflow is part of this. It can build a chatbot. You have categories. It identifies a predefined categories of what this text belongs to. This text belongs to news, mostly, internet and telecommunication. So it just classifies the text. Very important, one of the reasons, 80% of the products launches are measured using Twitters. People start writing positive, negative, movie reviews, everything. How do you identify that? How do you identify whether a campaign you ran is positive or negative? That's an answer. You don't need to reinvent the wheel. This is what I'm trying to say. Now let's talk about one last one before we talk a lot about the rest of them is, so what we have seen, Video Intelligence API, Vision API, and we have seen cloud, I mean, we have speech to text and text to speech. So you can take any text, speak it out. By the way, it doesn't understand sarcasm, which we Indians are very good at. But other than that, if you properly say something, it can identify that, convert it to the natural language, revert back. And the best part is call center analysis. This is a classic example I always tell, I don't know why, but take a call center guy, he actually answers a phone call, and you get pissed off because something getting answered. Now, how can you make it more better? Take the voice recording of it, convert it into text, send it to NLP, get the sentiment analysis, rise it, escalate it, don't escalate it, it's up to your need. You're done. Just connecting all these dots together, you're done. The next session is, the next variation of this is, if you wanted to build a proper chatbot, which actually order a pizza kind of, or book a movie ticket, Dialogflow comes into picture. Dialogflow gives you an ML base where you can start working your conversations on. So bunch of tools available for your consumption, for your usage. Not just that, we also built hardware. So I'm not going to go through everything because I explained. And this is how a recommendation engine can be built. Like if you wanted to build a next level YouTube or Hotstar, this is a proper blueprint. Take the video, put it in the cloud storage, use Video Intelligence, put the metadata to BigQuery, which is data warehousing solution, create a recommendation model, deploy the model, understand clickstream data, give you recommendations. Very simple. It is very hard to understand, but this is the blueprint. For people who are very noob or starting now, it takes a while, but try to understand. It can be done. It's not like it cannot be done. That's the whole point of conversation here. This is how media portals can be built. Now, If you are worried about, like, hey, I wanted to build a model which identifies Shah Rukh Khan as Shah Rukh Khan, or a car as a car, truck as a truck, maybe a dog as a dog. It's your own data, right? Because we give you some with a confidence level, but if you wanted to build your own stuff, that's the hardware we give you. This is TPU, way, way powerful than any other GPUs available in the market. One of the best features is, it will either, if you are a good ML person, it helps you to succeed quickly. If you are learning, it will help you to at least fail quickly without losing a lot of money, time, and energy. So what this gives you is, that pod is 11.5 petaflops. If you can understand what a petaflop is, don't think too much. It just makes your life easy. Just understand that. So that is given in a service which is machine learning engine, fully managed, which has TPUs, GPUs, and CPUs backend, and it helps you to reduce your time. Basically, all this cloud machine learning engine comes if you wanted to build your own model. As if you remember, there are 3 spectrums: a data scientist, a researcher, and an application developer. Application developer don't need to do anything, just to integrate these APIs properly, well-defined. This is where data scientists will come into picture. Understand the data, explore it, clean it up, put it across, and make best solutions out of it. And this is the service which can help you. 2 different areas. The right side, ready to use. Left side, train your own models. You choose based on it. See, our aim of Google Cloud is to give you as many options as possible. That's our aim. Your job is to learn and understand why these options are created. There is a reason why we create it. And start using it up, experimenting up. And you'll have more ideas than us, because all we use all these services is for our own purpose. Now, given this, you can build your own stuff. For example, how many of you guys actually wear Adidas brand t-shirts? How would you identify? Come on, how would you identify? Which service you use? Vision API, excellent. That's it. Put it across, take the picture, send it across, and it will identify how many times the shirt actually comes with Adidas. So all you just need to is focus on how to build the solutions rather than worrying about how they are built. And if you really focus on to build something new, TensorFlow. So fall back, use, start working. So how do you build a similar API of your choice? That's a crash course we give you. If you wanted to build something of your own, there is a crash course. Go ahead and take it. And this is for all the people who raised their hands when I said I love Max. Boss, if you don't complete that, I'm going to come to you. OK? So that is where the actual Max looks like. Thank you.